Hello everyone, welcome back to your favorite and India's most affordable learning platform, Physics Wala. So, in the last session of Laws of Motion, so the lecture number 3, where we discussed the concept of which one? The Newton's laws, right? So, we completely understood what is equilibrium, Newton's second law based question, and then impulse and change in momentum also we discussed it in the last class, right? So in today's session it's also going to be the important topic, so that is nothing but the spring force and the pseudo force. Here the inertial and non-inertial frames, which is very important topics, and most of the students they confuse in this topic. So we'll discuss in detail. If possible, we'll start it today, otherwise we'll wind up with the spring force itself. Okay, clear? So the spring force, as we discussed in the last class, the first class of the laws of motion, so there are different kinds of forces, right? So there are contact forces and non-contact forces. Under the contact forces we have seen tension force, the normal force we have seen, and there is one more force that's called the spring force, right? So that spring force we'll discuss today. Okay, and the combination of spring and string, if the masses are connected by spring and string, and how do we solve such questions, and what happens if we cut the string, or what happens when we cut the spring. So all such questions we are going to discuss it in today's session. So whatever the doubts that you are going to have, that you have related to the laws of motion, spring force, so they are going to be clear today. Okay, so just for the next 1 hour be with me, avoid all the disturbances around you guys, and at the end of the lecture it's very important to prepare your own short notes. Chalo, so with very high positive energy, so let's start the today's lecture. First, what is a spring force? The spring force is nothing but it's a restoring force, we can call. The spring force is a restoring force. The spring force, which is the restoring force, whose formula is given by, so we write it as the FSP. Spring force is a FSP, which is equals to Kx. The spring force is, which is Kx. Okay, so simply we take the magnitude, actually it's minus Kx, because it always restores a force. So let me explain clearly. So if a spring is stretched by distance x from its equilibrium position, for example, so this is the original spring. So consider, now I stretched the spring by some distance x. This is the original spring. So now we stretched it. So then the restoring force acts in such a way, so to restore its original position or original configuration. So whatever the spring's original configuration is there, so that should be retained, that should be restored. The spring force acts in such a way. Okay, so if it is, let's suppose if you stretch the spring, so then the restoring force will act towards its original position. Or if you compress the spring, let's suppose, so then the restoring force will act towards its original position. So for example, this is a spring, so consider you compressed this spring like this, some distance x you compressed, so then the spring force will act in this direction now. So whether it is compression or stretching, so the spring force will always act towards its original configuration. It tries to retain its original configuration. So what is the spring force formula? The spring force is equals to Kx. The spring force is equals to Kx. See, the simple way to understand the spring force is just compare it with the tension force. That's it. We know the tension force, right? Wherever there is a string, we apply the tension force. In the similar way, the same concept you can apply here. Wherever there is a spring, you apply the tension force, spring force. Okay, so and the same rules whatever you have applied for the tension force, you can apply the same rules for the spring also. Let me explain clearly. So let's suppose this is rigid support and this is one more rigid support. So here is a string, right? So now what we say, away from the support the tension T, and away from the support tension T. There is no mass in between, the tension remains same. So the same concept, if I say let's suppose, so this is the spring which is there between the two rigid support. So the same concept here, the spring away from this rigid support, the spring force FSP, and again away from this again FSP. As the total spring is same, so then the spring force is going to be same throughout this spring. So if there is mass comes in between, the tension changes. Here also, if the mass comes in between, the spring force changes. That's it. That's the only understanding you should have related to the spring force. So if you are getting confused somewhere, just imagine there is a string in place of spring. That's it. Clear? Chalo. So let's move further. Chalo. So for a massless spring, the spring force is same at both the ends, as I discussed earlier. See here. So this is a spring. One person is moving this side and one person is stretching this side, the spring. So here the spring force FSP, and then here also the spring force FSP. So what is the total change in the length? So the total change in the length, the total change in length, it's going to be x1 plus x2, right? So then the spring force will be equals to, what is the spring force? K into, so what is the total change in length? X1 plus x2. That's it. This is a spring force. This spring force will be same at both the ends, here and here. So generally students think that here it's kx2, here it is kx1. No, here it is k into x1 plus x2, here it is k into x1 plus x2. So at both the ends the spring force is same, k into x1 plus x2. Okay, so you should have that understanding. Clear? Next. So now let's understand through the questions. So mostly I'll take 10 questions or 11 questions in today's session related to springs, and we'll understand the concept one by one. Okay, so the first question, try to do it on your own, pause the video. So what's the question says here? Find the acceleration of 3 kg mass when acceleration of 2 kg mass is 2 meter per second square. So the acceleration of the 2 kg mass is 2 meter per second square. Obviously we know that the force is applied on the 2 kg mass, the acceleration will be towards right. Yes or no? So now the simple concept, first let me draw the free body diagram of 2 kg block. Consider this is the 2 kg block. Draw the free body diagram. So I can say that the 10 newtons is acting right side, and then its acceleration is 2 meter per second square, and then left side one force is acting, that is the spring force. Left side one force is acting, that is the spring force. Yes or no? So here this side, whenever there is a spring, this side the spring force will act FSP, and here also the spring force will act FSP, because this spring is same. So throughout the spring force remains constant, right? Yes. Chalo. So now see here. So here I can write, so the net force is towards right, because the acceleration is towards right, right? So I can write 10 minus FSP is equals to, 10 minus FSP is equals to, mass is 2 into the acceleration is 2. So from here I can write 10 minus FSP is equals to 4. So from here the spring force FSP is equals to 10 minus 4, 6 newtons is a spring force. We got the spring force now. So now next, what do we need? We got the spring force. So then let's find what is the acceleration of 3 kg block. So then draw the free body diagram of 3 kg block. So this is the 3 kg block, and then this side FSP is the spring force is acting, and right side is its acceleration. Let it be, acceleration will be right side. So there is no force acting right side, left side. Yes. Now write the equation. So the net force FSP is equals to, only force that is acting on the 3 kg block is FSP. So the net force is equals to mass 3 into the acceleration, right? So what is this one? FSP is 6 newtons, 3 into A. So from here the acceleration A is equals to 6 by 3, 2 meter per second square. 2 meter per second square. Simply the option D is the correct one. Clear? Understood, guys? Simple question. So let's move further. So let's take one more question. So what's the question says here? A mass m is connected to a spring whose spring constant is k. See here. So this spring constant is k. They mentioned it in the question. Okay. See here in the formula, did I mention here? I guess I forgot to write. See here, this k is nothing but the spring constant we call. Here, the k is the spring constant, guys. Right? Chalo. So whose units are Newton per meter? Yes or no? So what are the units of that? Force is newtons. If you send x to this side, so by x. So k is equals to FSP by x. FSP newtons are FSP units are newtons and x units are meters. So its units are Newton per meters. So now write the homework one. So what is the dimensional formula for this? The homework one is write the dimensions of spring constant. Write it in the comments. Write the dimensions of spring constant. Right? Chal. Next, see here. So here we know that this is a mass m, right? A spring is connected to mass m. So and then the spring force here that comes is FSP. So now if I draw the free body diagram of that mass, so here this is the mass. We know that upside the spring force is acting and then downside mg is acting, right? So find the extension of the spring when the block is at equilibrium position. So what is the see, what does it mean by equilibrium position? For example, you connected a mass to the spring. So then you left it. So then what happens? It oscillates for some time and after some time it comes to rest. After some time it comes to rest by some extension in the spring. So this is a mass. So then here there will be some extension. Let it be x. Yes or no? So I can say this is at the equilibrium position. At equilibrium position, try to understand the concept. Whenever you attach the mass to the spring, first what happens? It oscillates for some time. And after some time, it oscillates, and then it stretches, and then it comes to rest after some time. Yes or no? So then when it comes to rest, there will be some elongation in the spring. So what is that elongation or what is that extension in the spring that they are asking? So whenever the equilibrium position has come, the FSP should be balanced by the mg. The FSP should be balanced by mg. So what is FSP formula we have? So let the extension be x. So spring constant into extension is the FSP, which is equals to mg. So from here the extension is equals to simply mg by k. So therefore here the extension x is equals to mg by k. Option B is the correct answer. Clear? Done? Simple questions. Chalo. So let's see the next one. So what's the next question says? Find the extension of spring in equilibrium condition. Again the same thing here. So here whenever this side, so there is a pulley and this side it's a fixed support and then this side it's going to be the mass m. Yes or no? So whenever you attach this whole thing to the spring, what happens? The spring oscillates for some time and then after some time it comes to rest after some elongation, right? There will be some elongation in the spring. So let that elongation be x. So now write at the equilibrium position. I can write at equilibrium position. At equilibrium position. So there is some extension in the spring. Yes or no? When it comes to rest, equilibrium means when it comes to rest, there is some extension in the spring. Yes. So then you know that what are all the forces that are acting here. So write down the forces. The spring force FSP acts this side and then so here the tension T, so that here away from the pulley tension T and again away from the pulley tension T, again away from the rigid support tension T. So I could see that the FSP is balanced by the spring force is balanced by 2T. Yes or no? So the FSP, the spring force is balanced by 2T here. FSP is balanced by 2T. So then I can write here what is FSP. FSP is nothing but Kx is equals to 2 into T. So we can say that here, from here I can say that the T is equals to mg. The T is balanced by mg. You can write that, right? So in place of T you can write mg. So therefore T 2 mg. So then therefore x is equals to 2 mg by k. So 2 mg by k. So what is that? 2 mg by k. Option C is the correct one. Clear, guys? Understood? Chalo. So let's move for the next question. See, we are going one by one. Just understand the concept carefully. So now let's go for the fourth question. The masses are in motion. Here the masses are in motion. The reading of spring balance in kg will be. So this is the spring balance and which is attached to the pulley. So where here the masses are in motion. Obviously the 2 kg block will come down this side and 1 kg block will move upside with some acceleration a. This is simply the Atwood mission. Yes or no? So I can say that the FSP, what is that? Spring balance reading is nothing but what is the spring force? That spring force is nothing but the spring balance reading. So we have to find what is that FSP. So I can simply see that here, let's suppose the tension is T, here the tension is T. So here the tension is T, here the tension is T. So in the same like previous condition, so I could see that at equilibrium condition, at equilibrium position, let's write. So the FSP is balanced by 2T. The FSP is balanced by 2T. Yes or no? So now, shall I find, this is the simple Atwood mission. To find the tension of Atwood mission, we have the formula 2m1 m2 by m1 plus m2 into g. In the previous classes we discussed, right? So where we are discussing the pulley questions. So the simple pulley which is called the Atwood mission. So where that to find the tension we have T is equals to 2m1 m2 by m1 plus m2 into g. So now simply let's find what is FSP here. FSP is equals to 2 into, so I can write here this is 2 m1 m2 by m1 plus m2 into g. m1 m2 by m1 plus m2 into g. So from here 2 here into 2. So what is mass m1? 2 kg. m2 1 kg by, so m1 plus m2 2 plus 1 3. So and then this is going to be g. So this whole thing 2 into 2 into, so this is 8g by 3. So which is nothing but this is yes or no? So this is 2 into 2 4, 4 into 2 8. So which comes out to be, so 2 ones 3 ones are 3 twos are, and then 2 6 are 6 are. So like that it comes 2.66 g. So that means its weight, they are asking what is its weight. It's more than 3 kg? No. So 2.66 g means weight they are asking. See here. So what is the reading? The spring balance measures the weight, right? So which is nothing but the mg, gg cancel. You have to just see this value 2.66, right? So therefore more than 3 kg? No. So it is less than 3 kg. Yes. And then equal to 3 kg? No. So none of the above. No. So it is less than 3 kg, right? So if they asked you to find the acceleration, you can draw the free body diagram of each one. You know the procedure, right? 1 kg block, you draw the free body diagram. 2 kg block, you draw the free body diagram and write the equations for both and then calculate. That's it. Yes? Done? Understood the procedure? Chalo. So next. So here let's see this question. Find the extension in both the springs. So here is one spring, here is one spring, and here mass attached. See, I already discussed in the starting of the session. What's that? Whenever there is a mass comes in between the spring force changes. Whenever there is a mass comes in between the two strings, the tension force changes. In the similar way, whenever there is a mass comes in between, so the spring force changes. Okay. So now, so whenever the question is given like that, always start from the bottom block first. So First consider the bottom block. Consider the bottom block. See here. So draw the free body diagram of the 2 kg block. So this is a 2 kg block. So where the 2g is downward, right? And the upward force, which is FSP. The spring force, that is the force that acts in the spring, is FSP. And then its weight is 2g, right? So then I can simply say that here FSP is balanced by 2g. So from here FSP is nothing but k into x, which is equals to 2 into g. So k value they gave 100. So 100 into x is equals to 2 into, this is 10. Let's write g is equals to 10. So from here x is equals to 2 by 10. So which is nothing but 0.2. So the extension in the second one, it's going to be 0.2. So the second one 0.2, which is there in this one, this and this, right? So now let's calculate for the first one also. So let's calculate for the top block. Let's calculate in the top block as well. So where in the top block, so if you observe what are all the forces that are acting, I can say that here the spring force FSP will act. Here if the spring force is FSP, throughout the spring the spring force will be FSP. And here the spring force changes, let it be FSP dash. Let it be FSP dash. So now if I draw the free body diagram of the 1 kg block, I can say that, so its weight 1g act downward, its weight, and then downside FSP is downward, FSP is downward, and upward the FSP dash, upward the FSP dash. Understanding just the free body diagram. If you understand that, you can solve the question very easily. Okay, chalo. Now apply the Newton's second law here. So not Newton's second law, just apply the equilibrium condition. The FSP is balanced by, FSP dash is balanced by FSP plus 1g. That's it. So this force is balanced by these two forces. So then what is FSP dash? Let it be k x dash. The extension in the topmost spring is, let it be x dash. The extension in this will be x. Okay. So then what is FSP? So FSP we already got 2g. Let's write 2g. Understanding? FSP we are writing 2g plus this is 1g. So which is kx dash is equals to 3g. Right? So from here, so k is again here also 100. 100 into x dash is equals to 3 into 10. So 0 0 cancel. So therefore the x dash is equals to 3 by 10, which is nothing but 0.3. So the x dash is equals to 0.3. So the correct option is, one is 0.2, the other one is 0.3. So here they did not mention which one is which, and here directly you can choose 0.2, 0.3 is there in only option C. Okay, if they gave the sequence, this is A, this is B, so then it is going to be 0.3 and this is going to be 0.2. But here only in one option 0.2, 0.3 is there. So none of the options are matching. Clear? Done, guys? Next. So the same question. So let's delete this one. So next. So understand the question. Read the question carefully here. So there are two blocks are connected by a spring. There are two blocks are connected by a spring. The combination is suspended at rest from the string attached to the ceiling as shown in the figure. So two blocks are connected by spring, and then this whole combination is attached to a string to the ceiling, to the fixed rigid support, right? So the string breaks suddenly. The string breaks suddenly. So the acceleration of A and B just after the string is cut. See here. So the string cutting questions follow the standard procedure. Whatever I am going to discuss now. So that procedure you follow, the standard procedure. Okay. So I am going to solve at least 3 to 4 questions based on this. Try to understand the concept through these 3 to 4 questions. Okay. So first one, see the first step, calculate the forces at equilibrium. Calculate the forces at equilibrium. So then cut the string or spring. Then cut string or spring. Then cut string or spring. Okay, chalo. So this is the concept. So you will understand once I teach this question. See here first. So at equilibrium. So the first step, at equilibrium, draw the free body diagram of two blocks. Draw the free body diagram of two blocks. So always start with the bottommost block, the first M block free body diagram I am drawing. So for M block, what are all the forces that are acting? So here the FSP, the spring force, and downside the weight will act. So obviously I can say that downside mg, and then upside the force that is acting is FSP. Now write the equilibrium condition. So FSP is equals to mg. Yes or no? See, at equilibrium means, so when you suspend this oscillates for some time, and then so it elongates, and then it comes to equilibrium. That's a concept. Just imagine a spring in your hand. So and then you attach a mass. So till that time you are holding the mass. Once you release the mass, what happens? So the mass oscillates for some time, then it comes to rest after some elongation in the spring, right? So that's the concept. The same thing here also. So the FSP will be equals to mg. So here I can write, so the kx is equals to mg. So let it be aside. Now consider the 2m block. So draw the 2m block. For 2m block, above tension T is acting because here it is a string. So here is string T, so that, and here the FSP downside it is acting. Downside the FSP is acting, and again its weight 2mg is acting downside. So I can say that the tension will be equals to 2mg plus FSP. 2mg plus FSP. So now the tension is equals to 2mg. In place of FSP I can write mg. In place of FSP I can write mg. So therefore, so the tension is equals to total 3 mg. So the tension is equals to total 3 mg. Yes or no? Clear this part? So this is at the equilibrium. So now what you do is cut the string. Now cut the string. Cut the string. So when you cut the string, what happens? The tension becomes 0. So when you cut the string, the tension becomes 0. The tension in the string becomes 0. Yes or no? Now draw the free body diagram of A block and B block after cutting the string. So this is the A block, this is the 2M block. So for 2M block, if you cut the string, there is no tension upwards. Previously the tension is there. So now there is no tension. So only the forces that are acting are 2mg downward, and then so the other force that is acting is FSP. 2mg downward and FSP, so that it accelerates downward. I can say it accelerates downward. So therefore I can write the acceleration of A block, right? So which is equals to net force by net mass. Net force by net mass. What is the net force of this? 2mg plus FSP by, so the mass of that is 2m. The mass of that is 2m. So then 2mg plus, what is this one? FSP is simply mg. So 2mg plus mg. So 3mg by 2m. So which is nothing but, so I can write 3mg by 2m. mm cancel. So 3g by 2. So the first one is 3g by 2. So now take the B block after the string cutting. So I can say the FSP is acting upside, and then the mg is acting downside. This is a block B. I am considering FSP is acting upside, mg is acting downside. So now what is the acceleration? The acceleration is equals to Fnet by Mnet. Fnet by Mnet. So what is the net force? So either you can take FSP more or mg more. Mg minus FSP I am taking by, so the mass. So we know that the FSP is also equals to mg. We know that the FSP is also equals to mg. So that's why in place of FSP I am writing mg. So mg minus mg 0. So therefore the acceleration of block B is 0 and acceleration of block A is 3g by 2. The acceleration of block A is 3g by 2. Clear? So one is 3g by 2, the other one is 0. So check the correct option. Option D. So again I am explaining this question. Just follow the standard procedure. First, for the two blocks at the equilibrium position, find the what are the forces acting on that. So first I took the 2m, first I took the bottom block. So where m block, so the FSP is acting upward, its weight mg is acting downward. FSP is equals to mg from this one. And then for 2m block, so the tension is acting upward, FSP is acting downward, 2mg is acting downward. So therefore T is equals to 2mg plus FSP. 2mg plus FSP. So here T is equals to 2mg plus, in place of FSP, shall I write mg? So therefore T is equals to 3mg. These are at the equilibrium. Okay. So now cut the string. If they asked you to cut the string, so cut the string. Or if they asked you to cut the spring, cut the spring. Okay, whatever it is. So here just after the string is cut, they said. So if the string is cut, the tension will become 0. Now draw the free body diagrams of A and B again. So for A block, there is no tension force now. Only forces that are acting is its weight 2mg, and downside the spring force. Spring is still there. So that's why spring force. So the acceleration, the total force is downward. Obviously the acceleration will be downward. Yes or no? So the acceleration of A is equals to the net force acting on it by the net mass. So net force is 2mg is its weight and FSP is acting down. So 2mg plus FSP by its weight. So which is its mass 2m. So this is 2mg and FSP we already got here mg. So in place of FSP I substituted mg. So this is 3mg by 2m, which is 3g by 2. And for B block, FSP is acting upward and its weight is acting downward mg. So the A is equals to F net by m net. So as I know FSP is also equals to mg, I can write either mg minus FSP or FSP minus mg. That's your wish. Okay. So then this is going to be 0. So here the acceleration of A 3g by 2. So which side it is? In the question sometimes they may ask which side it is. It is downwards. This is downwards. Clear? Understood? Sure. So let's solve one more question related to this. Let's take this question, guys. Two blocks A and B are same mass m attached with a light string are suspended from a spring as shown in the figure. Find the acceleration of A and B block just after the string is cut. See here, just after the string is cut. Follow the standard procedure. First step, at equilibrium position. The first step is at equilibrium position. The first step is at the equilibrium position. So consider the bottommost block. Consider the bottommost block. B block I am considering. So for the B block, this is a B block. So whose mass is m, so that its weight mg will act downward, and then the tension T will act upside. Here the string is there here. So whenever there is a string, the tension force. Here also the tension force. So here spring is there. So here FSP, and here also FSP downward. Yes. So these are the forces you should represent. So I can say that the T is equals to simply its weight mg at equilibrium position for B block. So now consider the A block. Consider the A block. For A block, the spring force is upside, and then the tension is downside, and its own weight is there mg. Yes or no? Spring force upward, its weight mg downward, and tension is also there. So from here I can say that the FSP is equals to T plus mg. The FSP is equals to T plus mg. So the FSP is equals to what is T? In place of, see here, in place of T shall I write mg? Mg plus mg. So therefore the FSP is equals to 2mg. The FSP is equals to 2mg. So this is clear. Just at the equilibrium I drew the free body diagrams and I wrote the equations. Nothing more than that. Alright. Chalo, next. So now after string is cut, now cut the string. After string is cut, what happens? the tension in the string will become 0. The tension in the string will become 0. So now draw the free body diagram of B and A. So if I draw the free body diagram of B, so what are the forces acting on B now? Its weight mg is acting. So, and it is connected by string. There is no string force now. There is no tension force now. So the tension is 0. No need to write. So obviously the only force acting is mg downwards. So that's why it accelerates downwards. So therefore the acceleration of B is equals to, so the net force acting on it by the net mass. Right? What is the net force acting on it? Mg is the net force by what is the net mass? The mass of the block B is m. So that's why m cancel. So the acceleration of B is g downwards. The acceleration of B is g downwards. Clear? Understood, guys? The acceleration of B is g downwards. And similarly, let's draw the free body diagram for A block. So let's draw the free body diagram for A block. This is the A block. So where the FSP is upside, and then so its weight mg is downward, and now there is no tension force. See here, downside the tension should be there here. The tension force here, the FSP, and then here the weight will be there, but the tension after string is cut, there is no tension. So I can say that so the axle FSP is how much? FSP is 2 mg, tension is mg. See here, FSP is 2 mg. This is, write it down here, 2 mg. This is mg. Obviously the acceleration will be upward. Acceleration will be upward. So now the acceleration of A will be equals to, so FSP is more force minus mg by its mass. What is the mass of block A? M. So which is 2 mg minus mg by m. So which is mg by m, which is again g, right? So therefore the acceleration of A is g, which side? Upwards. G upwards. Clear, guys? Understood the concept now? Chalo. So let's move further. This is the question number 7. So let's take one more question based on the same concept. Let's take one more question. So pause the video, now try to do it on your own. Two blocks A and B of masses 3m and m and are respectively connected by a massless and inextensible string. These are two connected by string, and the whole system is suspended by a massless spring to the rigid support. Okay, so the magnitudes of acceleration of A and B immediately after the string is cut. So just after the string is cut, what are the accelerations of A and B? Same questions. First, at equilibrium position. First, at the equilibrium position. So at equilibrium positions I can write. So first bottommost block you take. So B block. So for the B block, I could see that the tension force upside and its weight mg downward. These are only two forces, right? So the T is upward and its weight mg is downward. So that's why the T will be equals to simply mg at equilibrium. Let it be aside. So now consider the A block. So now consider the A block. So for the A block, what are the forces that are acting? So I can say that upside the spring force is there, and downside here the tension force, and its weight 3 mg. Right? It first thing, its weight 3 mg, and downside string is there. So that's why the tension force T, and upside spring is there. That's why the spring force FSP. So now I can write here FSP is equals to T plus 3 mg. T plus 3 mg. So then here I can write FSP is equals to, what is T? In place of T, shall I write mg? Mg plus 3 mg. So which is FSP is equals to 4 mg. FSP is equals to 4 mg. Okay, these are at the equilibrium. So now the string is cut. See here in the question, the string is cut. So again write down. So after string is cut, the tension force is equals to 0, I can say. So now draw the free body diagrams of B block and A block again. So for the B block, I could see that, so tension force 0, there is no tension force now after string is cut. See here. So now we cut the string, right? So if the string is cut, there is no tension force. Only force that is acting is, it's the weight downward, right? Mg downward. So and then obviously its acceleration will be downward. So therefore the acceleration of B is equals to the net force acting, its weight, by its mass m. So m cancel. The acceleration of B is, which is equals to g downwards. The acceleration of B is g downwards. So in the similar way, draw for the A block now. So for A block, I could see that the spring force is upside. Here the spring force will be there upside, and then its weight 3 mg downside. That's it. There is no tension force now. The string is cut, right? So now I can see that. So the FSP, so here the acceleration will be, which side it is more? See here, downside 3 mg, and FSP is equals to 4 mg, right? So this is 4 mg. Obviously the acceleration will be upward. Yes or no? So therefore the acceleration of A is net force. What is the net force? 4 mg minus 3 mg. FSP minus 3 mg, which is nothing but 4 mg minus 3 mg, by the mass of it is 3m. So which is 3 mg minus 4 mg minus 3 mg, mg by 3m. So m cancel, which is g by 3 upwards. The acceleration of A is g by 3 upwards, and acceleration of B is g. Check the option. So A is g by 3, B is g. So A is, acceleration of A is g by 3, B is g. So first they asked A and B, right? G by 3 g. Option B is the correct one. For the previous question, did we put the options? So for the previous question, the options are G, G. See here, it's the previous question, it is B. So in the 8th question, it is again B, G by 3 comma G. So sometimes they may give upwards downwards. Okay, so you should be careful with the directions as well. Hope you guys understood the string cutting and spring cutting questions. Clear? The procedure is clear, everyone? Done? Now let's move further. Now, so the combination of springs. So if the springs are connected in series and parallel combination, see here, this combination is called the series combination of the springs, and this combination is called the parallel combination of the springs. Okay, so here first it's just reverse as the resistances. Okay, reverse of resistance formulas. It's just the reverse of resistance formulas. In the resistance case, you have studied in the grade 10th, right? So the equivalent resistance in the case of series is equals to R1 plus R2 plus R3 till goes on. And in the case of parallel, 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3, like that. But here it is a reverse. So in the series combination, the K equivalent, 1 by K equivalent is equals to, here only 2 springs are there. That's why 1 by K1 plus 1 by K2. 1 by K1 plus 1 by K2. Or you can also write this as, so the 1 by Ke is equals to K1 K2 is the LCM. Here K1 plus K2. So therefore Ke is equals to K1 K2 by K1 plus K2. If there are only 2 springs which are connected in the parallel combination. Series combination, sorry. This is a series combination. So whereas in the parallel combination, so the K equivalent is equals to simply the K1 plus K2. So and if there are more springs, let it be K3, K4, like that. This is K1, consider this is K2, the spring constants. So then the K equivalent is K1 plus K2 plus K3. So in the resistance case, it's reverse, right? This formula comes for parallel, this formula comes for series. But there you write R in terms of in the place of K. Just reverse of the resistances you have to write. Done? Clear? Chalo. So no need of derivation, just understand the concept. So here some complex questions also can be framed. So we'll take some complex questions at the end of this chapter. Okay, so which were asked in the previous year JEE and NEET. So here I am going to teach you first the basic concepts, then at the end of the lecture I'll conduct one session, so where we will solve the complete previous year questions. Okay, sure. So see this question, the question 9 was, what's the question says? Two springs of springs constant K1 and K2 joined in series. So then the effective spring constant of the combination is given by. So K1 and K2 series. So the effective one formula is what in the series combination? 1 by K1 plus 1 by K2. Is there any option? No. We have to solve it further. 1 by K equivalent is equals to, so K1 K2 LCM. So here K1 plus K2. So then here the K equivalent will be equals to K1 K2 by the K1 plus K2, right? So this is a concept. So the K equivalent is equals to K1 K2 by K1 plus K2, option D, right? Simple question, direct formula based one. So next, so the parts of the spring, see here. So parts of the spring means, let's suppose, so this whole spring has some length L and the spring constant K. This whole spring has length L and spring constant K. So now what I am doing is, so I am cutting this spring into two equal halves. I am cutting this spring into two equal halves, see here, so that its length will become L by 2 and then its length will become L by 2. The spring we cut it into two equal halves. So its length is L by 2, its length is L by 2. So then what are the spring constants of each half? What are the spring constants of each half? See here, the spring constant, simply it is inversely proportional to the length. The spring constant, it is inversely proportional to the length. So if it is L by 2, its spring constant will be 2K and its spring constant will be 3K. Okay. So or else, let's suppose, if I cut the same spring into three equal halves, let's say the same spring is cut into three equal halves. So here let's consider L by 3. So here let's consider L by 3. So here let's consider L by 3. So then the spring constant of each part will be 3K, here 3K, here also 3K. Or else, let's suppose, so this is one example, this is a example 2, and then I am taking the example 3. So consider a spring is cut into, let's suppose, so 1:2:3 ratio. 1:2:3 ratio. Total it is cut into how many parts? 3:1. 6 parts it's cut, right? So the first part is of 1 by 6 times the length, one part, right? 1 out of 6, 1 by 6 times the L. So the second one is 2 by 6 times the L, and the third one is 3 by 6 times the L. See here, the total length is L. So the first part is one part, just simply 1 out of how many parts? 6 parts. 1 out of 6 of total length. Here the second one is 2 parts out of the 6 into total length. So here third one is 3 parts out of total 6 parts into the length L. So then I can write here that 1 by 6 times L, this is 1 by 3 times L, this is 1 by 2 times L. Yes or no? So that the spring constants will be just reverse. So here the 6K, here the 3K, and here the 2K. That's it. Understood the concept? So now clear everyone? So or else let's take one more example. So if I cut it in the ratio 2:3:4, let's say, so this is the first one, so 3 parts and then 4 parts. So obviously the first part length will be how much? So 2L by total how many? 7 plus 2, 9. The second one 3L by 9. The fourth one, the third one 4L by 9. Yes or no? So that this is 2L by 9. So this is going to be L by 3, I can write. So what is the spring constant of this? Just reverse this one. So 9 by 2 times the K. just reverse this one, 9 by 2 times a k. So this is 3k, its spring constant. Its spring constant will be 9 by 4 times a k, 9 by 4 times a k. Understood the concept, everyone? So these are the parts of the spring. Done? Everyone clear with this? Chal. So now let's take one question based on this. Let's take one question, so which was asked in NEET 2017. So let's try this question on your own. What's the question says? If a spring of force constant k is cut into lengths of lengths in the ratio 1:2:3, they are connected in series and the new force constant is k dash, and then they are connected in parallel and the new force constant is k double dash. So then the ratio of k dash to k double dash. So that's what they are asking. See here, first there is a spring. Understand the question properly. First there is a spring, so which is cut into 1:2:3 ratio. And how many total, how many parts? 3 plus 2 5, 5 plus 1 6 parts, right? So total 6 parts, 1 2 3. So 6 parts means like this, one part is 1 ratio, the second one is 2 parts, that's third one is 3 parts, like that. Okay, so see here, so the first one will become 1 by 6 times the L, the second one 2 by 6 times the L, the third one 3 by 6 times the whole length. So that it's going to be 1 by 6 times the L only. This is 2 by 6 means 1 by 3 times the L. Here it is 1 by 2 times the L, right? So this is, its spring constant is 6k, its spring constant is 3k, its spring constant is 2k. That's it. Now we have got the spring constant, each part's spring constant. Now what they are saying in the question, see here. So they are connected in the series. First, if they are connected in the series, let's find what is k dash. So if they are connected in the series, the new force constant is k dash. So now the new force constant 1 by k dash is equals to 1 by, what is k1? 6k plus 1 by 3k plus 1 by 2k plus 1 by 2k, right? Chal. So here 1 by k dash is equals to, here the total LCM is going to be 6k. So here it is 1, here it is 2, here it is 3. So therefore 1 by k dash is equals to, so 6 by 6k. So here 6 cancel. So the k dash is equals to k. So this is when they are connected in the series. So then next let's find when they are connected in parallel. Let's find when they are connected in parallel. So in the case of parallel, the k equivalent they gave in the question as k double dash. So which is equals to, we have got k1 plus k2 plus k3, direct formula. So what is k1? 6k plus 3k plus 2k. 6k plus 3k plus 2k. So which is total 11k is a k double dash, right? So then what is the ratio they are asking? So what's the ratio of k dash to k double dash? So k dash to k double dash. So k dash is given as k double dash is 11k. So k cancel. So therefore k dash to k double dash ratio is 1:11. It's 1:11. Clear? Understood, guys, the concept, everyone? Chalo. So that's about the spring forces. So that's it from my end for today's class. So in the tomorrow's session, we are going to start the very important topic again, that is inertial and non-inertial frame, and there comes a pseudo force concept. Okay, so that pseudo force, how do we apply and how do we solve different questions, and what are the standard results to be remembered, all those things we'll cover it in the next session. So that's going to be very important session, and don't leave the session, just sit there for 10 minutes and write your own short notes of today's session. Okay, and when you come to the next session, revise all the topics of the short notes. Okay, chalo. So we'll meet in the next session, guys. So till then, keep studying. All the very best. Bye.